Hi, so this is a really good question I got. Uh, it's a combination of both LeetCode and Struct, so I think it can sharpen my skills in both of those categories in C++, which are like really important for interviews. And for this question, I got it from Claude. This is a difficulty hard question, so you could like read the instructions over here. This question includes the sliding window. All right, you're given an array of integers num and an integer k. A sliding window of size k moves from left to right. All right, so we are gonna have an array of n size, and then we can make, I guess, windows or like sub arrays of size k from that array. All right, for each window or for each sub array, we are gonna make a struct that will include these attributes. All right, so got you. And over here, we could actually see some helping functions or helping code snippets. So this is gonna be the struct. This is our function signature, and this is our example. So if this is an array, and we have our k is equal to 3, these are the sub arrays from this main array. So 313, 135. All right, so yeah, got you. All right, let's do it then. So, are stream are using namespace std. I always like to include this. I know most of the developers don't do it. They just they do this, but I like to keep it this way. Int main. Return 0. All right, so they haven't mentioned our time complexity. So let's see where we could actually go from here. What I'm thinking, the approach that I'm thinking I think will be O n raised to power 2. So it's not very optimal, but that's what I'm like thinking right now. So let's see if we could implement that. All right, so we are gonna have a struct. Let's define our word struct. Let's call it window. And okay, it's gonna have some attributes. Max value, max index, window sum, right? And max value, and was it sum? Yeah, max index sum, max index and sum, and then we have bool if maximum value appears twice. Bool has multiple maxima, multiple maxima. Alright, we have our struct. Now we can define our function. So our function is gonna be a vector. Let me include that as well. Include vectors. Is it vectors or vector? Yeah, it's vector. Yeah. Right. So we can define our function. So we are gonna return a vector that will have our struct objects. So we can just like do this. Let's call this function sliding window. All right, it's gonna take all right, it's gonna take a vector of int, and we are gonna give it a vector of int using by reference, so it doesn't make a copy. That's more efficient. Let's put it ARR, I guess. Yeah, wow. And then we are gonna have our k, which is just a constant number. All right, now I think we can start working on it. So let's see. So first, all right. So first, I think we should make sub arrays. how we can like do that. The approach that I'm thinking, int I is equal to 0, I is less than arr dot size, and arr I plus plus. Okay, so right now what's going to happen is it's going to iterate over everything, and then we will have an other loop, and j is less than all right, let's see, less than, we could just do I plus k. So if it's 0, and then if we plus 3 or whatever here, then it's gonna get to 3. So yeah, I think that should work, right? Yeah, I guess so. Then j plus plus. But the thing over here is, if we get to the last index in our array, and then we plus k in that, or like let's assume like k is 3, all right, and our array has a size of, let's say, all right, and comma 1 2, right? This is just a rough example. For the first iteration, our I is equal to is gonna be equal to 0. Actually, let's put I over here. Yeah. So it's gonna be 0. Then we are adding 3 in it, or whatever the case. Yeah, 3. So 0, this 1, 2, and 3. Now less than 3. Yeah. So over here 64. So it's gonna get to here 264. All right. Then we are moving. Then I, for the next iteration, I is gonna be 1. So it's gonna come at come to 43, and then from here again we are going 3 steps forward. But the problem is, if we come here and if we try to go 3 steps over, we're gonna exceed our index, and that's gonna give us an error. So that's not very optimal. But if we actually minus k here, like if we do this, so size is 1 2 3 4, so it's gonna get to 3. Yeah. Okay, so if we minus k, so it's gonna come over here 21, and 21 is less than I plus k. I plus k is gonna be 3 because I is 0. 3, all right, and then then it's gonna like come over here, and then this, and yeah, we could just put equal here to get to the last item as well. Yeah, I guess that's working. Nice. Okay, so if we actually try it, I guess, I mean, I don't think that we have like tried. I know it's working. All right, so what's our next step? For each of our sub array, okay, let me actually make 2 vectors here. Vector int, let's name it a, and then another vector that is gonna store this vector. So it's gonna be vector int b this, and in this vector a dot pushback, we could actually store our sub arrays, and we can just do this a dot pushback j. Yeah, it's gonna store this, and then over here, I guess, yeah, and we in our b vector or our main vector, we could actually append it. Yeah, we could actually implement append a, and then we can clear a. Yeah, like this. This seems to be working. Now we have this vector that includes all of the subarrays from our given vector or our input vector. Now we can actually iterate over that vector. Int I is equal to 0, I is less than b dot size, I plus plus. Okay. Now for each of our vector, we have to like find these things. Yeah, I guess pretty simple from here, I guess. Let's see. B I, yeah. Okay, so int max value is equal to bi dot max. Yeah, sorry, it's like this. Max element bi dot begin, comma bi dot end. But I think this thing, yeah, it is from algorithm, I'm pretty sure. Oh yeah, it's okay, nice. But the thing is, this thing is not gonna return the actual value. This returns the pointer to the actual value. So if you guys know that, actually, if I would have a pencil over here, I could actually show it to you. Do I have anything? I don't. No, I don't have anything. All right, but as you guys know, in our memory we have an array which stores our elements in a contiguous form. This thing is not going to return the actual element from that array. Instead, it is returning an index, or you could say pointer, or a memory address of that specific element. So we have to like dereference it to get the actual element, which is like this. Yeah. Now we have our max value. Now what we need? Now we need index of that maximum. All right. So let's see. You know what? Let's go with auto. Max index. Actually, I forgot how did you implement this find. I mean, you could like do something to get this. You know what? Actually, let's find the index of that element. All right, let's say max index is equal to 0. Now we have int j is equal to I1. J is less than b j not bj, yeah, bi. My mind is not working now. Dot size j plus plus. now we could just like do if b I j is greater than ai max index, then we could just do this. Yeah. Okay. So if this function runs, it means our max index is not at 0. Otherwise, it's gonna change our max index. That's why I am like going from ji, from second element, not from the first. Because if it's the first element, then we could just like use this, you know. Because then it's not the if statement is not gonna run, and our max index is gonna stay 0. So yeah, I think it should work. Yeah. Okay, for our next element, we need sum of all elements. All right, for sum, actually, we could actually implement for loop in that category as well, but I don't think so. We need to do that. So as I remember, we have a library, numeric, I guess, numeric. Yeah, and it does provide something related to sum. I think it was accumulate. And sum is equal to accumulate, and then b I do begin, comma b I. Sorry, what? Oh, sorry, I came out of the loop. What? Why is that? I think we need to put this. Yeah. Okay, this just means that where we wanna like start it from, where we want the sum to start. All right. So from our first index or first element, so that's gonna be 0 at 0 index. I hope that makes sense. And then what we need is okay, bool. Okay, we need if there is another max value, right? So I guess for that we can run one more loop. Bool has, let's put it false, and then we can do for int j is equal to 0, j is less than b I dot size, and then we could just do j plus plus, and now we can do is if if okay, we want to see if this value has appeared more than once in our array, so we could just do if max value is equal to our arrays sum. So we could just like bi. Okay, so bi, if you, I hope that you know it by this point, but bi refers to the sub array in this bigger array. It is like just referring to the sub arrays in this bigger array, and then if we do this, now this j is referring to each element of that subarray. I hope that makes sense. If this and count is greater than equal to 1, oh sorry, count greater than equal to 1. Okay, so if this is the case, it means that our max value has appeared twice, so we could just like do this. Bool has true. Otherwise max value, else if max value is equal to b I j and count is less than 1. Come on, what the hell? In this situation, we will just add 1 to count. Come on, what the hell? Like this. Yeah, I think this should work. Pretty hopeful for this. Okay, we got all of the elements. Let's start putting them inside our struct. Okay, so there is one thing. Okay, I wanna like try window A. This is just our object, nothing fancy. If let's see if it's if this aggregate initialization is working. I learned it like in yesterday, I guess. Let's see. So first of all, we have to implement our max value, comma. Oh yeah, it's working. Nice. Max index, comma. Then we have our sum, comma. Then we have our has. Yeah. Okay. So this thing, this line, is okay. You call it aggregate initialization. Is similar to it's similar to this actually. Let's say if we do this, sum is equal to sum. This line is similar to this, but instead of doing it separately, instead of initializing every attribute separately, you just initialize everything in one line. So it's pretty convenient in my opinion. All right, so we have our object. Now let's make another vector of type window. Vector, call it final, I guess. And in this final vector, let's final dot pushback. Let's put a. Yeah. All right. Now we can just like return our vector. Okay. So just to be clear, I also wanna point this out that you might be wondering that we are looping over. I mean, we are creating this object from the struct every time we iterate. So this object is because we are not copying anything. This object is gonna override its memory again and again. But since we have copied this object to this memory, to the other memory, so it doesn't matter. So if it overrides its previous memory, I don't think so that should concern us. All right, let's call our vector int arr. What? Let's see, 3.1 3,1 3524 comma 3524, and our k is gonna be 3. Yeah. What? Oh yeah. Now let's call our function. So since it is returning a vector of type window, we can store our results here, so we can print it later. Sliding window. All right, so it is taking, oh yeah, we have already defined the type. So all right, now we can like print it. We could just do auto this are in resource. Okay, I just put this because I didn't want it. I want it to make a copy, but doesn't matter. We are not gonna run out of space, that's for sure. And so our max value is gonna be what? Is gonna be our dot max value. Then our index, column index is gonna be r dot max index, and then our sum is gonna be r dot sum, and at last our it was just say duplicate this, and then we could just do r dot, yeah, and we need everything on the new line, so we could just do this. This is gonna print every count statement on the new line. All right, let's see. Oh, 36. And max index is equal to 0 if bij is. What the hell is going on here? We're trying to find the maximum value. Why have I put a over here? Let's run it now. Alright. So 1, 2, 3. How many windows should have been there? Let's see. Where is our main function? Yeah. 1, 2. Okay, there should have been like. Okay. Something is wrong, for sure. I'm not too sure. Okay, sum is right, I guess. 336. Okay, sum is not even right. What the hell? That's crazy. Alright, so the issue was over here when we are creating our object, we have duplicated this thing. This should have been max value. Plus, if we look at our logic over here, for in j is equal to 0, j less than b at the side, j plus plus, if max value is equal to this and count is greater than equal to 1, then has is true. If that's not the case, Hmm. Okay, this is gonna, I mean, this should run actually. Count plus plus. Let's see if it's running. Duplicate 1, 0, 1, 2, 3. Okay, I guess this, yeah, it's working fine now. Because our first sub window is gonna be this. Over here, our sum is maximum value is 3. Index is 0. Sum is 7. Duplicate is 1, 3. So yeah, nice. I think it's working now. Yeah, so this was the question for sliding window. If you learned anything, tell me in the comments, I guess. Alright, so the issue was over here when we are creating our object, we have duplicated this thing. This should have been max value. Plus, if we look at our logic over here, for in j is equal to 0, j less than b at the side, j plus plus, if max value is equal to this and count is greater than equal to 1, then has is true. If that's not the case, okay, this is gonna, I mean, this should run actually. Count plus plus. Let's see if it's running. Duplicate 1, 0, 1, 2, 3. Okay, I guess this, yeah, it's working fine now. Because our first sub window is gonna be this. Over here, our sum is maximum value is 3. Index is 0. Sum is 7. Duplicate is 1, 3. So yeah, nice. I think it's working now. Yeah, so this was the question for sliding window. If you learned anything, tell me in the comments, I guess.